So, yeah, good morning, everyone. Once again, thank you for joining this. Okay. Um, is there anyone in the waiting room? I don't think so. No. So yeah, thank you so much. Okay. Yeah, time is of essence. Absolutely. That's why I'm starting now. Thank you, Tessa. So yeah, thanks so much for joining, everyone. This is gonna be more like a presentation and more like a practical session on using GE for your research project. We shouldn't limit our mindset to what they are teaching us in school. So that's actually the motivation behind this presentation and training, because we are to embark on research projects, which is very important for our graduation. And you know, in the past, it has some kind of archaic way of going through it, as downloading and using the normal software that we are familiar with. And for the past few years as well, there has been some, progress in the industry on how to make our work faster and easier. And one of the two developed in the process is Google Earth Engine. And up to now, we haven't been introduced to it, and that's very bad. So when I found out about it, I just felt to be a great, um, you know, to be great to introduce it to all of us so we can get to use it for our project and to make our work easier and faster. Google Earth Engine has been in existence since 2016 also, but it's been in existence for over 5 years. I'm very sure of that. And up to now, we haven't been introduced to it formally, in the school setting. So thankfully, I came across it in last year, and I found out that it's very good for research projects, for the kind of analysis we do in the department and our project. So it eliminates a lot of stress, and that's what we want, to save time and energy. So yeah, let's proceed. So the content of this presentation is going to, I'll give a general overview of Google Earth Engine, prerequisites, and practical demonstration, most importantly. That's the most important thing. Then I'll share some resources on how to, proceed, and how to, what next to do from here. So the Google Earth Engine, GE. So GE is an acronym for Google Earth Engine. It's just like a Netflix for satellite imageries. We have Netflix, and on Netflix you can search for movies. You can filter movies based on categories or genres, or you can do all sorts of things with when it comes to movies on Netflix. You can save movies, you can download movies, you can watch, you can pause, you can come back again to resume watching. You can share movies, right? So that's just the concept behind Netflix, behind Google Earth Engine. Normally, if you want to, access satellite imagery, you have to go to a particular site to access it. But with Google Earth Engine, everything is embedded in that single platform. Imagine if you want to download a movie on Netflix, then you have to, go to a different site to maybe copy the URL of that movie, then come back to Netflix to paste the URL to start watching. I mean, that's a lot of stress, right? So everything is, fully packed in a single platform. So you go there, log in, watch, do anything you want to do, you know. So that's the concept of Google Earth Engine. We have satellite imageries that are being collected every day, every second, like petabyte of data available in the world from 1972 when Landsat was launched. So and we do researches, right? We embark on projects that require us to access those data sets. So don't you think we should have a platform where we can easily access this data set, and not only access or download, and also analyze them as well? So those are the things Google Earth Engine can be used for. So Google Earth Engine is a planetary scale platform for earth science data and analysis. It's developed by Google actually, and it's powered by Google Cloud Infrastructure. So, cloud technology has been the buzzword in recent times. So, uh, Google Earth Engine leverages cloud such that if you want to perform any analysis, it's going to be performed on the cloud, right? So it makes it easy to perform large scale analysis. Imagine if you're working on a project and your study area is the whole of Southwest or the whole of Nigeria. I'm very sure a tiny laptop cannot be used to run the analysis, right? Even with the little study area or small study area we are working on, ArcMap do hang on unexpectedly. So it's leveraging cloud platform and cloud infrastructure, you can get to run analysis at a large scale, region analysis, um, continent analysis, and even global analysis. And it's very easy, although there are not much GUI, like graphical user interface, but you can do some analysis with writing a few lines of code. So, that also makes one to gain additional skills and become relevant. When you find yourself, wherever you find yourself in the future, tell them that you can use Google Earth Engine to do this and this. And, all organizations are looking for ways to automate their task, to make things faster and get results and insights as soon as, you can. So you eliminating the need to go to the particular site to download imagery, then importing, even sometime before you even import, you get to convert your imagery, change it from one format to another. For example, CSV, yeah, something like that. So, and some, for example, maybe converting GeoTIFF to ECW or converting GeoPackage to GeoTIFF or something, this kind of stress can, it's just been eliminated from Google Earth Engine. And also sometimes most of the sites don't really give us a general overview of the data sets we are collecting. And that's very important in remote sensing analysis when it comes to best practices. Say, for example, you want to do land use land cover. What's the right satellite imagery to use for it? What's the, Landsat has a lot of versions. We have Landsat Tier 1, which is more like the direct image from the satellites. We have Tier 2, which is more like the one that has been pre-processed. We have TOA, top of atmospheric reflectance, that has been pre-processed as well. We have SR, surface reflectance, that has been atmospherically corrected. So we have, different versions and flavors of this satellite imagery. Same thing with Sentinel, Sentinel 1B, Sentinel 2A, Sentinel 1C, like that. So sometimes we are just always quick to download because even the process of downloading is not interesting at all. So we don't even want to waste time on those platforms. We just go there, download, and get out of there and import in our maybe ArcMap or QGIS and start running analysis. And the concept of garbage in, garbage out also applies. This data might not be the best for analysis, and that's why we often get poor results. And I know most of us would like to, publish our papers after school. So imagine you publishing something with poor results, and maybe at the end of the whole thing, the maybe reviewer of the research is not asking you to go and redo your analysis. That this is not a valid analysis, right? So Google Earth Engine has a catalog where you can get to see each images and um, the bands available in those images and some brief description of what has been done to those images, so you can know where to start from, and also some coding session like a snippet that you can just copy and use immediately without even writing code at all. So you can also leverage some machine learning algorithms for classification. Normally in the classification we use an ArcMap, minimum distance, unsupervised classification, maximum likelihood, those kind of classifications. They actually machine learning algorithms. So you can also access the same thing in Google Earth Engine. Even more advanced, you can access clustering algorithms, supervised classification, nearest neighbor, and the likes. So all this is might sound big, but the developers of Google Earth Engine have made everything easier. So, okay. So, so you can just go there, and leverage those algorithms. Like they have abstracted the whole process, just like they did in ArcMap as well, where you just go there and okay. So so you just go there and a few clicks, maybe pick out your sample point, training data set, and run the algorithm, and you get your classified imagery. So you can also leverage the same thing. It has been abstracted. You just call a few functions and you get to do it, and you run it and you get your result ASAP. Then you import it, maybe ArcMap or ArcPro or QGIS, and you proceed with your analysis. So like I said, there are a lot of images that are being collected every second, every day. We have a lot of CubeSats in space. We have a lot of satellite imageries. We have a lot of sensors out there in the space that collect data. So it can be overwhelming sometimes when you want to download data as well. You don't know the path arrow for the one you want to download. You don't know if the imagery you're downloading is covering your area. Sometimes we download images and they're not covering our stored area, waste of time and data and energy. So I have to go back and download it again. Sometimes we download imagery that has cloud cover, wasting a lot of data to download images with cloud cover. It's not really not cool. So with Google Earth Engine, we can do all those things by filtering. So we can filter images and just get the right one for our use case. So then also you can import shape files, we can import shape files, you can import all sorts of data as well. I will show us all those as we proceed. And they are more to Google Earth Engine because you can also create apps, like web apps. For example, if you're working on a time series analysis, you can create a website, like a web app that has a few widgets, where maybe when user drags a widget, maybe interacts with it, the user will see the forest cover, or maybe land use, in the year the user selected. So you can also create website that you can share. You can also share your code. I can write a code now, for example, for NDVI, that I can share it with you. And what you just do is to maybe change your study area and run the code as well, and you get the same result. So it makes things faster. Like when I think how I even got to know about Google Earth Engine was when I was reading through a thread in Stack Overflow, and I saw that someone shared a link to Google Earth Engine. I just clicked the link and I saw the code the person wrote, and I was like, "Wow, this is sweet." That means I might not even need to write much code. I'll just read through the code the person wrote, understand the logic, then maybe change a few variables, and run the same code and use it for my use case. Then I'll move on from there. So it makes code sharing easier, and and that makes work faster a lot. So I think I've mentioned this earlier. There's the usual workflow we are familiar with. Going to Earth Explorer to download imagery. It's computationally intensive to use this kind of imagery. One sat, at least Landsat 8 is around 1 GB. And when you're downloading Landsat of 1 GB and you want to do NDVI, that means you need just band 4 and band 5 of the old 1 GB that you downloaded. And that's that's a waste of resources. Wouldn't it be nice if you can have a platform where you can filter and select just the bands you need, and don't care about the other bands. You understand? Or you want to do an LST, you need band 4, band 5, and let's say band 10. But you can't do the same thing. You just have to download the whole imagery, which is about 1 gig. Start selecting the band you need. And the remaining bands are a waste of storage, waste of resources, and so it requires high storage, and most of us, our computer machine are low storage devices, and we're downloading a lot of Landsats. It will get to a point where we won't have any storage on our device again, and we'll have to start getting maybe external hard drive to store data. And also we can perform analysis on the fly. You can't do any filtering, for example, maybe to filter just the band you want and download only those bands. It's not possible. You just have to download your imagery. That's a waste of time. You can't do NDVI on this platform. You can't do language non-cover. You can't do anything. It's just meant for download. And there are lots of them like that. A lot of data access portals. So Google Earth Engine is just a platform that combines those data access portals such that you can search for any data available on Google Earth Engine and use it. So you don't need to go to this platform again, or any other platform. You just use Google Earth Engine for everything, and you make a lot of progress. So yeah, let's do some practical demonstration so we can get to understand Google Earth Engine better. So the prerequisite for Google Earth Engine, that's the first thing, and that's to have an account. And to have an account, you have to sign up. I've been sending this URL to the group, I think since a few weeks ago, so you can get to sign up and, you know, enter your email, your full name, affiliation. Let's say for the University of Technology, Akure, for example, institution time, academia. So you can use your footer email here, for example. Then, check these two boxes. Click this as well. Select your region, that will be Nigeria. So what would we like to accomplish with Earth Engine? My research project, as simple as that. And you can elaborate, as you desire. Then you submit. That's all. So once that is done, then you have access to this platform. So when that is done, you have access to this platform, which is the Google Earth Engine console, right? So this is where you'll be able to write your code and do all sorts of analysis. Next one is the code editor. So yeah, this is the code editor. So let me walk you through the code editor. So this code editor, right here we have Google Earth Engine logo. Then beside it, we have search places and data sets. So this is where you get to search for data sets you want to use, right? Let's say you want to use Landsat, just type Landsat. You're going to see a lot of results. Places as like address, we have a place called Landsat Z in Germany. Raster, which is data, we have a lot of these. Then tables, we have a lot of these. So you can see there are different flavors of Landsat. We have Landsat 8, Collection 1, Tier 1, OLI, Raw Sense, like a lot of them. So you can get to know if this is suitable for your research just by clicking on it. So when you click on it, you get to see the availability of the data sets. Let's say you want to do land use mark over from 2020 to 2010 to 2020. You know that, okay, this one is from 2013 to 2020. So you'll be like, okay, this can be good for 2020, but you can't get 2010 from here. So instantly, you know that you need to go back and select another one, right? So you can also read this description of the data sets to know what is here, and to just learn more about the data set you're planning to use. Then bands, you can click on bands to see the available bands and their resolution and wavelength. So low, green, red, near infrared, shortwave, PQA, bit mask. So they use this actually for correction, atmospheric correction, and radiometric correction. I think it's even here. Cloud, cloud masking to remove mask from, to remove cloud shadows from your imagery. So this is like a raw image, right? There are some images that they've done all this analysis on, and then you can just leverage without performing any correction or any pre-processing again. And if you have to use ArcMap, for example, you can get this kind of images. Let me just, you can close here. Let me just show those type of images. So I can't see any of it here. So you can just click on more. So you can see like a catalog view. Oops. Okay. Okay, sorry, let me stop sharing and try something. I can pause recording. So as I was saying, you can get to have an overview of the available data set, and you can scroll down to check for Let me just check for surface reflectance. Yeah, you can see this data set is the atmospherically corrected surface reflectance from Landsat 8 OLIT sensor. So this has been corrected. Normally if you want to do correction like this in ArcMap, we are going to download the old Landsat, like the raw Landsat image. Then we are going to open our what's it called again? Is it band calculator of is it field calculator? What's the name of that tool in ArcMap that we use to calculate do this numerical calculation? I think it's field calculator. You're going to open it and start doing some kind of calculation, or maybe using the model builder to run the algorithm to calculate and correct our imagery. But with this, it's very easy. So it's already done for us. We just need to import it by clicking here to start using it. But I won't import yet. I'm just trying to show us one of the functionalities of the code editor. So you can search for Landsat, and it's not a Landsat, Sentinel, for example. You can search for Sentinel as well. So you can see we have Sentinel 1, 2, 1, there's 1C, there's 2A. We have near real-time nitrogen dioxide, the Sentinel 5P. So if you're probably working on maybe air quality, you want to use this Sentinel 5P. I once used it for something like that. So you get to see the air quality of the study area you're working on. Nitrogen dioxide. It's one of the contributors to poor air quality. So you can also click on more as well to see some other available Sentinel data from Copernicus. So MODIS, just basically, you can search for any data set here, right? For those that are working on rainfall chips, just search for chips, rainfall data, you see it, you can read about it, understand, can read about it, the available bands. It's just precipitation that is there. So, and that's what rainfall is. I can also see how to cite it. So if you're working on a research, in your project, that's the document report, you can put this in the reference section if you want to cite this platform, like this data set I used. So yeah, basically any data set and even address, you can search for any address. Let's see Lagos, for example. If I click on Lagos, you can see the map view has changed to Lagos, right? So yeah, this for searching for data sets. Then we have here your profile, your account will be here. Let me drag this. Yeah, your profile account will show you. We have here where you can get to see the user guide. You can see the developer question and answer forum, the discussion group, general source and shortcut, and feature tool. So let me click on this feature tool. You see that, okay, welcome to Earth Engine code editor, take it all, I click on next. It's going to show me this side, like this is where we have the scripts, which are like the codes you'll be writing. We have the docs here, where you get to see documentation of the available functions and algorithms. Everything there. Here. You have assets. This is where you're going to see all your uploaded shapefile, for example. So the first thing you want to do is to create a repository or a folder to store your scripts. So as you can see, you can see different repositories here. These are repositories, just to segment and separate different kind of project I'm working on. For example, for today's training, this is the one I created for it to store the scripts I'll be using for today's training in the repository. So this makes things cleaner, right? So if you want to, if you come back here and you want to resume a project or analysis, you just go back to the one you want to work on and you proceed. And you can also filter just to search for the one you're looking for. So also in the docs, you can filter. Let's say you want to filter for image collection, for example. Just search for it and click on it. Then you read to see how it's being used. So then this is the code. This is where you write the code. This interface right here. This is where you type your code. The right here you have the console. This is where you print out results. Funny enough, it's using print, which is a function that we are familiar with in Python. Normally when you're trying to print to the console something in JavaScript, you use console.log, but it uses print, and it's right here. Use print to write to this console. Then if you're exporting, for example, it's going to show on that task. And you're going to see the task you're exporting to your Google Drive, right? And if you're inspecting, you're going to see, like, let's say you want to inspect something on the map. Even the cursor has changed. The moment I clicked on that inspect, if I click on console, the cursor is going to be like a normal and the cursor that will allow me to pan around. Click on inspector, it's going to change. So I can inspect anything I'm working on. And we're going to explore this as we proceed. So I think that's that for this side. Then for here, you can get the link. This way you can get to share your code. You can get the link by clicking on it, then copy this and paste it in the so anywhere you want to share it, and you're going to see like the person you are sharing it with is going to see the same thing with you, and the person can duplicate it and use it for his own project as well. So then you can save. Of course, you have to save every just try to save occasionally, and you can use Ctrl S instead of pressing here. Just type Ctrl S. Then this is where you press to run your script. Click on run, and it's going to run your script. Then you can reset as well. And this is what you use if you want to manage your apps. There's some general settings. So that was all about the upper part. Then the lower part is the map view, where you get to see your results, on the map. You can draw a polygon with this. That's to draw a rectangle. That's if you're just creating your shapefile on the platform. You don't have to import. You can create your shapefile on the platform. You can draw a polygon and a regular polygon. You can draw a point. You can draw a line. You can just do all sorts of drawing. So let me remove them by deleting. So anything you draw is going to come up here as import. So this is the polygon right here. This rectangle. It's named geometry. So if I expand this, I'll see that it's a type of polygon. And if I expand this as well, I'll see the coordinates. This is the top left, bottom corner, the coordinates of the edges of the polygon. So they're always 5, and the first is always equals to the last. That's, when they are joining together. So that's why it's like this. So this is a GeoJSON format. So let me remove it from here. That was a walkthrough of the interface. Absolutely, I would. So that's the walkthrough of the interface. Then you have satellite. You can change the map to satellite view, to terrain view, for example. So satellite view. It's going to change the satellite view. Then you can change the normal map and activate the terrain if you want to activate it. You can see. You can make it full screen. And you can press escape to change from full screen. You can zoom with your mouse, zoom out. You can zoom out to the world scale, pan to your country. There's a way you can also do this zooming and zooming out with the code. I'll show us that as we proceed as well. You can also use this to zoom in and zoom out. So what else haven't I showed you? I don't know if you have any questions so far. Do you have any questions so far?
No question. You can just continue.
Okay, cool. So also Google Earth Engine have some examples here, like some example sample codes that you can use to, you can see you have normalized difference. You click on it, you're going to see the codes for normalized difference, like how to calculate normalized difference. And let's say we just run this directly without even making any edits there. You're going to see the NDVI for that study area that Google used as example. Same thing with Hillshade. If I click on this, it's going to load here. If I run this as well without touching the code, I'm going to see the Hillshade for the study area Google used in their example. Same thing with like a lot of them like that, a lot of algorithms that you can just run without even changing them, right? Just run the algorithm and you're going to see the results. So when you run a particular script and you have a result on the map, you'll see them under layers. So here you can check and check the results. You can click on these settings. So maybe change the visualization, for example. Maybe you can increase the stretch to 90%. You can change the band, filter the band. And the way we doing ArcMap, if you want to visualize, instead of band 3, 2, 1, you can make it maybe band 4, 3, and 2. Then you apply it. Then when you apply it, you observe the difference on the map. You can see band 432 is different from the band 321. So you can just do all sorts of um, changes or visualization there. So you can reduce the opacity as well, can increase the opacity. At the beginning, you're working on multiple layers and they're overlapping. You can just reduce the opacity of one so you can see what's underneath. You can also increase the opacity. You can check one, so it's very flexible. So there are a lot of examples here from Google, like a lot of it. In fact, what you want to do might just be right here. So for example, you want to do NDVI, just click on NDVI, read the comments they wrote there. Maybe what you just want to do is to maybe clip it to your, let me just run this. I think they did this I think it's for the whole world. So that means if I zoom out, let me try and zoom out. Yeah, you can see the NDVI is for the whole world. So maybe what you just want to do is to just zoom to your study area and just clip it out. That's all. You can't do NDVI for the whole world with ArcMap or QGIS. You can't even try it. So it's, platforms like this, you can get to do a large scale analysis without making use of any resources because everything you're doing here is done on Google platform, like Google Cloud platform, their server. So you're just leveraging it and it's absolutely free. So it's just very interesting. So next up is introducing JavaScript for Google Earth Engine. So yeah, let's do that quickly. Let's just introduce JavaScript for Google Earth Engine. So JavaScript is a web-based programming language, actually. It's a language for the web. And you don't have any prior experience with programming before you pick up JavaScript. It's very easy to pick up. You understand? So, but if you're coming with a programming background, you pick it up very fast. So GS is broad, and this GS here is the GS for Google Earth Engine because there are some GS magic that you can perform here. For example, you can use the ES6 syntax, which supports defining functions with const, right? The syntactic sugar. You're not able to do those kind of stuff here, or with, but you can also use normal functions, right? So there are just some minor similarities and differences with the normal JS that we know, and the JS for Google Earth Engine. So yeah, let's start with comments. If you want to comment out something in JavaScript or in Google Earth Engine, you can use this double slash. So if I remove this double slash, you're going to see this warning that this is an error. But once I put this double slash there, the one is going to go. So this is a comment, and this comment means that this is not part of the code. It's just some text to better explain the code I'm writing, such that if I send it to someone else, they'll be able to understand that, okay, this is what this line of code is doing. So that's what comments are used for. So also we have multi-line comments. So this is for single line comments. If I come to the second line and start typing, this will not work. It's going to throw an error, right? But if I want to write a multi-line comment, like maybe write a 5-line of comments, I'll use this to do that. So this supports multi-line comments so that I can write in as much I'm within this forward slash and asterisk and forward slash, in as much it is encompassing this anything I want to write here. It's not going to throw an error, and it's going to consider it as comment. So the editor is going to just skip these ones and move to actual snippets that I want to run. That's why if I run this, you can't see any of this here, which is the console. So the console is where we get to see the results of the code we are running. So that's that about comments. Now we have integers. Integers are just whole numbers, they are whole numbers, right? Normal integers in mathematics. So you can see I use the comment here again to say that, okay, these are integers, just to make it descriptive. So, and this is how we define a variable in JavaScript. If you want to define a variable, let's say you want to, just any variable, right? Use the var keyword, just like a short form for variable. Like we do in mathematics, we say s is equals to 5, y equals to 4, but you can't do that here. You have to just append it with this var. So the editor can know that, okay, this is a variable. So we can now say, okay, var x is equals to 42, and this 42 here is an integer. That's a whole number, right? So you can also, use, add some dots to it. Maybe it's not a whole number, maybe it's a float or a decimal. You can also do that here as well. So you can just say var x is like the variable name equals to this, and that's how define. So let me just print it out so you can see that. So to print out, we use the print function, print the answer. So if I run this again, I'm going to say 42 here because I already assigned this 42 to this variable. So I don't need to say print 42 again. Once I say print the answer, it's going to show me this 42 that's already assigned to this variable. So that's how we define variables and integers. So next up is string. So string is used to store letters, characters, alphabet. Right here I have variable 1. This is a string. This is how we assign variables, right? Variable 2 equals to this is a string. So the difference is that in integer I don't have any quotation mark or anything. I wrote it directly like a normal number. But when it comes to string, you have to put it in quotation marks, either single quotes or double quotes. They'll work, but it should not be really two. Like, don't mix single quotes with double quotes. You can see the errors showing here. So the editor is so smart that you get to see some, warnings here if you are not doing the right thing. So choose one. If you want to use single quotes, use single quotes. If you want to use double quotes, use double quotes. And the both works. So let me try and print one on the screen. You can see this is a string. If I print the second one as well, This is also a string. So they both works. Either you use single quote or double quote, but don't mix the two together. So those are called strings. Then there's a convention in JavaScript. Normally in Python, when you write code, you don't need to add a semicolon or anything. You just write your code and you move on. But in JavaScript, it's advisable to write, to append with semicolon. That's why you can see it's showing this I. If I remove the semicolon here now, for example, it's going to show this. And if you hover on it, you're going to see that it's saying that a semicolon is missing here. So if I add it here again, it's going to remove the I. The semicolon is to show the end of statement or end of a particular code snippet. It won't affect your code if you do not append semicolon. Nothing's going to happen. The code is still going to run, but that's the convention in JavaScript. So anytime you write a code, append a semicolon with it. If you're not comfortable with this, you can just write your code. Then when you are done, you can now go back to append semicolon. I come from a Python background, so I wasn't comfortable with it at first, but I'm getting used to it now. So as you proceed, as you write codes, you get used to writing, appending semicolon at the end of your codes. That's just JavaScript convention. So we have parentheses, those brackets. So this is what we use to execute functions, like I've been doing since. I'll write print, then in brackets, the variable I want to print out, right? So we can do print without brackets and say I want to print out this variable. It's not going to work. It's going to throw an error. So we have to put it in a bracket. And it's not just only print, any function we want to call. Now I'll show you what I mean by that when we get here. So yeah, we have to append semicolon. It's very important. So then we have something we call lists. So list is like a bucket for storing, data, for example. This can store any kind of data. So you can say you have a list of universities, and in that list you have strings, like we looked above. Any character must be in quotation marks. So we have string, we have footer, we have Uniben, we have OAU. So if I print UniList, for example, you're going to see footer, Uniben, and OAU. So you can see each of these items in the list, they have their own index that we can use to access them.
0, 1, 2,
You can have a list of 1 million items, like just so long, but you can always access them with the index. That's their position actually. So, and the index starts from 0 in Python. So footer is in 0 position, Uniben is in the first as 1, Lee is in 2, like that. If I want to access footer, for example, I'll just say UniList, which is this, then put a square bracket in front and type 0. So if I run this now, I'm going to see footer, because footer is in the 0th position. If I put 1 here, it's going to show me the item in the first position, which is Uniben. Again, it starts from 0. So 0, if you expand it, you're going to see that it's even in front of it, 0, 1, 2. So that's how list works in JavaScript. Then we have something we call dictionary. So dictionary is used to store key value pairs. For example, you want to write a composition about yourself. Let me print the composition. So you can see how it looks like. So this is the composition. It's also code object in JavaScript. If I expand this, you're going to see department is RSG, food is spread, my label is 400, school is footer. So it's different from list because list you just store them like in a straight line. Footer, what does footer mean? Uniben. But because I know that is a list of schools, so yeah. But with dictionary, you can mix different things and just give them a key and a value. You understand? For example, this list here, list, I can also add it to this dictionary, right? I just add it here by saying schools. The value is unit list. So when I run this and I expand this again, You see that I have department, RSG, food, bread, level 400, school, footer, schools, list. I can also expand those schools again. Then I'll now see footer, Uniben, and AU. So they are key value pairs. They make, to make stuff to be descriptive, you get to store different. Dictionary can hold a list can hold the dictionary. This composition, for example, I can put it in this list, right? Can I? Let me try it. Yeah, I can. So if okay, I can't. Showing no undefined. Cool. So yeah, a list can be stored in a dictionary, but I think a dictionary cannot be stored in a list. Let me try this. And you can have a lot of lists in the list as well. Yeah, you can have multiple lists in the list. It's not working. Wow, that was interesting. Interesting discovery. So they are very flexible. You can just play with them and see. And you can also access items in dictionary, for example, like we did here in list that we use one to access Uniben. You can access department. The same thing, square brackets. But instead of using 0, 1, and 2, you use the key right here. And these are the keys, the first item and the keys: food, school, department, level. Those are the keys. So you can access with the key. So that's why if I run this, you're going to see that the stream in RSG because I accessed with the key department. And the value for department is RSG, right? You can also access using the dot notation. Instead of using square brackets, you can use dots. So if I want to access department, I'll just say composition, which is the name of the variable stored in the dictionary, dot department. All right, as well, I'm going to see RSG, the same thing. So then finally, let's go to functions. And functions are, I used to make our code cleaner and easier to read, to avoid repetition. Now you can divide all your sections into different functions and you just call it when you need it. So you have a function and the function must return something. It must receive or accept an argument and it must return something, right? So let's say I want to have a function that prints out hello world or hello plus the name of anybody that called the function or any parameter or argument you use to call the function. So I'm going to call, I'm going to define the function that's okay. Variable test function is assigned to function. This is how you call function in JavaScript. Function, then in brackets, the arguments we want. It can be more than one. You can have another argument here. Of course, I used arguments. You should maybe change it to be more descriptive, like name and class. Let's see that. Let's say level, for example. Just can set more than one argument. So then you open the curly brackets. And you use this a lot in JavaScript. Then you return what you want to return. So you can see hello, this hello is a string. You can see it's inside curly brackets plus the argument, which is now name, plus exclamation mark. You can also append with you are in plus level plus level. So it's called all I'm doing actually is just string concatenation, right? You can concatenate a string. What does that mean? That means that you can add different strings together. So let's say we have a string 1 equals to Jeff. Then we have string 2 equals to Emmanuel, for example. You can concatenate these two together. That's like joining them together. So if I say print string 1 plus string 2, you can see Jeff Emmanuel. So it's going to join them together. So that's called string concatenation. Let's say I want to do like print out Jeff 3 times. I can just do string 1 times 3. And when I run this, oh, that's not working. Interesting. But that should work in the normal JavaScript. So That means you have to do string 1 plus string 1 plus string 1 for me to see Jeff, for example. Beautiful. So you can do string concatenation right here. So that's what I'm doing in this function. I'm just returning hello, which is this, plus name. And that name is the name the person is going to pass in this function, which is this, Emmanuel. Let me pass in level. Level will be 400. So plus name, that's hello plus Emmanuel, with the exclamation mark, that's plus this, plus UI in, that's this, UI in. Let me put some space here so that it won't be so close together. UI in plus level, that's the level the person is going to pass in. And here I passed in 400. So UI in 400, then plus level. So when I run this now, I should see hello Emmanuel in 400 level. So let me add a space between in and 400. That would be here. So anyway, I want to use this function now, I can call it anywhere. So I don't need to be typing hello, you are in 400 level, like again, I just call this function and I pass in these two parameters, the name and the level. It can be anything, it can be any argument. It just can be maybe passing the band you want for NDVI. Maybe just passing band 1 and band 2. So if I'm calling this function now, I just have to pass in maybe the band 4 and band 5. So instead of just returning, we'll be returning, maybe arithmetic is like band 4 minus band 5 over band 4 plus band 5. You understand? So you can use this function for practically anything you want to do. So that's just a general overview of JavaScript for Google Earth Engine. It's very important to understand it. So even if you are maybe using the examples here from Google, or you find a script online or something, be able to understand what the script is doing. For example, if I click on this normalize difference from Google, I know that these are comments automatically. I know this cannot run because these are comments, they already used the double slash as I told us earlier. Then they also used to make what the code does descriptive. This one says load a modis image. And this is a variable named image, and it's equals to this, to load an image. Then this is a variable named ndvi, and they use this function that receives this parameter, this argument and this argument. I know this is a list, which is named palette, that holds these codes. So these are X codes for visualization purposes. Because without this, if I run this ndvi script, for example, I won't see. It's going to be in black and white actually. It's in black and white, but with the help of this hexagon codes here, if I run this again, it's going to show it in in colored mode, right? You can see it's been colored. So this is because I understand the basics of JavaScript, so I can be able to even edit the code to my own use case, right? So that's just the same thing that happens when we have a general overview of a particular language. So JS basics is very important. You can just come back here to understand the basics, and I'll be sharing some resources also at the end of this presentation on where to learn more on JavaScript. So once you know JavaScript, if you see a code in Stack Overflow, if you see a code anywhere, you'll be able to understand it and just copy the one that you need, or maybe modify it to your use case. So you won't need to write many lines of code like that, for example. The next up is the dataset catalog. So the dataset catalog allows us to learn more about a data. I think you can see view data catalog. Look, even without searching for it, let me just go back. Let me see if it's going to be somewhere here. Yeah, it's here. Just click on this drop down. You're going to see view data catalog. So when you click on this, it's going to take you to a page where you'll be able to see the available data sets in the Google Earth Engine, right? For those that are working with climate and weather, you see the surface temperature, you see the climate, you see weather, you're going to see atmospheric, you see Landsat imagery, Sentinel imagery collection, you see high resolution imagery, you see Moody's. For geophysical application, you're going to see them here. For land use non-cover, yeah, I use it in my research project. Land use non-cover is here. I just click my study area and that's all. And this for I think for the whole of Africa from European Space Agency, and it's very detailed. So I just load this in Google Earth Engine, click my study area, and that's all. Just took it out to embellish in that map. You can see like saves a lot of time. Cropland and some other geophysical data like nighttime imagery, like that, so you can explore the data set there. And also you can follow these videos, the Twitter account, Stack Exchange, Medium, and GitHub to learn more about Google Earth Engine and to interact with other developers, for example, or to ask your questions. So let's just click on one. Let's click on the one we are all familiar with. Let's say you want to do Landsat, for example. Just click on Explore Landsat. So when you click on Landsat, you're going to see all about Landsat. Not all actually, but like some overview of Landsat. You can see from 1972 to the present day. It's a joint program from NASA and USGS. You get to see those key information about Landsat. You can see the logo here. Then you have different flavors of Landsat. You have Landsat 8. You're going to see the date, 2013 to present. Landsat 7, 1997 to present. Landsat 5, 1984 to 2012. Landsat 1 to 5, 1970 to 1999. So even if you want to work in the project for a particular year, coming down here, you already know they want to select. You want to do NDVI for 2020. You already know you can select either Landsat 7 or Landsat 8 because Landsat 5 ends in 2012, so you can have 2020 imagery. You understand? So even with these dates, you know that, okay, this is the one that will be good for my project. You want to do image analysis for 1970 something or 1980 something, then you're going to use all these ones, Landsat 1 to 5 or Landsat 4. So let's check on Landsat 8. So also learn more about it. So Landsat 8 also has its own different flavors. You have surface reflectance, you have top of TOA, top of atmosphere reflectance, we have the raw imagery itself. Then more interestingly, we also have some, more interesting is that we also have some derived data sets like burnt area index, enhanced vegetation index, NDVI, normalized burn ratio thermal, NDSI, NDWI. So all these ones, we have them for 8-day, 32-day, and they have different distance there. So you can just select anyone you want to do and just click your study area, and that's all, without you even writing any code. Like they are derived data set already, right?
Wow.
So anyone you want to use, just click on it. Let's say, for example, you want to do NDVI for Akure, just check for NDVI. It's still the same formula. You can see it. They wrote it here. NIR minus red over NIR plus red. Let's say you want to do annual NDVI. Click on annual NDVI. You scroll down to see the code snippet. This is the code snippet for annual NDVI. Just click on open in code editor. It's going to open the editor for you. Load the code that you saw in that previous screen, and it's going to run it for you. Right? So maybe what you just need to do is just to maybe load in your shapefile and just clip it out and export to your Google Drive. That's all. No stress or anything. So it's super interesting. The documentation is just amazing. And they also reference the algorithm they used for the computation. They did this NDVI based off top of atmosphere reflectance. And that's the one we saw here. This one, COA. So you can know that, okay, this image has been corrected before they calculated the NDVI. They also give it some insights on the kind of correction you should use before you calculate some analysis, the kind of images you should use, not just raw images for NDVI, because raw imagery is going to have a lot of errors, errors. So this will give an insight that, okay, since Landsat to use TOA reflectance for their NDVI calculation, that means I think TOA reflectance, this one, would be a good one for NDVI. All right. So you can, of course, see the bands available, check the image properties, description of the image. You can also do the same thing. Open a code editor. This is the one we opened the other time. Yeah, this one we opened the other time. So this is anywhere for the award. So you can just zoom to your study area and clip out your study area, and that's all. Saves a lot of time. So that's the catalog. And it's not the last that we have here. We have Modis, we have Tensinel, right? So you can just explore them, open the one you want to work with, understand the data sets, what it does. Because I understood the basics of JavaScript, I can easily understand this code, right? So it's not like I'm copying blindly, just using their code. I understand what is happening here before I open the code editor. So it's very important to always have an understanding of the basics of JavaScript or Google Earth Engine before copying and pasting code blindly, so that maybe during defense or maybe when you are writing your report, you'll be able to say that, okay, you did it yourself with the assistance of maybe Google Earth Engine documentation or something. So let's think about what's next. You have featuring images. Yeah, so let's write some codes and filter image and do some NDVI analysis and let's see how it's been done. So before I go to filter images, I think I already showed us this, but docs is here. In case you have any issues, you can always come here to read the documentation, right? So I think I just have to mention that. So if you want to filter an image, the first thing you want to do is to load the image. That's the first thing. And the image is called, like the function load for loading the image is called image collection. So what the function does is it loads an image, that's a Landsat image, using the ID. All those images I was showing earlier, they have their ID. Let me just search for a random Landsat, for example. So let me say I want to use this Landsat 8. If I click on it, and let's say I want to import it. Okay, it's in here. Yeah, collection snippet. So this is the ID of this Landsat. Landsat LCO8 CO1 TI underscore RT. You can also see examples. By clicking on that, and it's going to bring me to this place, and it's going to show me the example of like the just a lot of resources to help us make things faster and easier. So how do I import? I click on import. So it's going to be on the top. It's going to be here. The variable name is going to be image collection. So you can just change it to Landsat or anything you want to do. So now that I've changed it to Landsat, let me just print it out first. Let me print out Landsat 8 first, so you can see how it looks like. So let me run this. So when you print out an image collection, I throw an error because that's you printing out the whole of the Landsat 8 image in the world, and that's a lot. It even says this right here. Collection query aborted after accumulating over 5,000 elements. So you can use this to limit it. So you can say, okay, don't print out the whole of Landsat, just give me 50. I want to see just 50. So when you run this, you're going to bring out just 50. So when you expand this and you go to features, you're going to see the first 50 Landsats in the image collection. You can see Landsat, they have 12 bands. So you expand this one, you see the bands available, band 1, band 2, band 3, band 4. So normally you can also check the properties. So yeah, cloud cover, it's on distance. The normal things we see in Landsat metadata, right? They also here as well. So now let's do filtering of Landsat. I mean, this is too much. We don't need this all of Landsat. Let's filter Landsat to just the area you're interested in. So let me also show you how to import a shapefile. So you can use it to filter. So if to import a shapefile, you go to assets. So another asset you see your imported data, right? So you click on new. You can also import a raster as well. You can import a CSV. You can import folder, image collection. So just click on shapefiles. Then you select the folder you want to import it. Obviously, it's going to be your asset ID. That's user/general money. That's this one here. Then you can give it a name. Let's say you want to give it, let's say study area. Then let's select the files. So let me select my study area for my project. I think it should be somewhere. Yeah, study area. So it says it here that the allowed extension are SHP. They are here. So I think CPG is there. So you select CPG, DBF, PRJ, SHP, and SHX. So you open it. So then you click on upload. So once you click on upload, it's going to create a task here. So this task is that it's going to tell you that it's uploading study area to your asset. It's going to show the progress that is still ingesting it. I'm still injecting it. Can you hear me?
Yes, boss. They follow you, sir.
Okay. Thanks. So still injecting it. So when it's done injecting it, that's more like uploading your shapefile to the cloud. So you can access it here and use it for anything you want to use it for. So let me refresh this to be sure that it's there. Okay.
Please, oh, can you hear me? I can't hear anything now.
I can hear you. I can hear you, wide, loud and clear. Let me refresh again. It's not here yet. Just still injecting it. Let's wait for it. So yeah, it's done injecting it. So let me refresh this page now. Yeah, it is ready. So I can click on this and I'm going to see my study area. It's going to load the thumbnail for me. Yeah, this is my study area. So I can import this.
We just small.
So when I import this, it's going to come here as a table. Again, I can always change the variable name to study area. So it can be more descriptive. So yeah, so let's filter an image collection. That's the Landsat image collection. So let's say we want to use Landsat 8. And we have filtered it here. We named it Landsat 8. So to filter, we're going to use a variable name, that's the image collection, Landsat 8. Then dot filter. There are a lot of filtering functions here. If you go to docs and you type filter, you're going to see a lot of them. You can filter by date, like a lot of filtering. So in case you have any issues, you can just copy it to check them out. So let's filter by bounds. So our filter by bounds allows us to filter, so our study as our region of interest. So filter by bounds accepts a variable or an argument. And one of the arguments is the study area we're trying to filter. So that's the study area that I imported from my assets, right? So it's right here. So if I run this, let me comment out this first. And let me run this. Just filtering by bounds, right? And let's see the results. So we're not seeing anything because it's not throwing error, and because this Kansas City is not where my study area is. If I zoom out, for example, and I go to Nigeria, where my study area is. Let me run it again and see if it's going to show any Landsat imagery here. Oh, okay, let me just print it. I'm not printing it, that's why I'm not saying anything. So let me print image. Yeah, so we have 737 Landsat scenes that covers my study area. You can see we have filtered from the last one that had over 5,000. So we have 2014. So the image of my study area has been coming from 2014, 2015, 2016, 17, 18, 19, 2020, and even 2021. So that's the first thing, filtering by your study area. So the next thing you want to do is to filter, let's say by date. Maybe you want to work on 2020 image, for example. You just need 2020 image. So you can filter by date. The first one was filtered by bounds. You can put it in the front. But in JavaScript, like I said, so far there is no semicolon. Your code is still going to run. So that's why I can continue on the second line. All right, just to make it look neat. So let me continue here. Filter by bounds. That's my study area now. Filter by date. So let's say we want to filter with 2018 from the beginning of 2018, that's 2018, the year, the month, that's January, and the day, that's January 1 to December 31st. So let's do that and see the response. Now we have 737 elements. If we run this, it should be reduced at least. Yeah, I can see we have just 91 now. So this has been, we're just printing out actually. So let me just add let me add them to map so we can get to see them on the map. So we use this function map.add layer to add an item to the map. And one of the parameters it accepts is the, what you want to add to map, maybe an image collection. This is an image collection because it's more than one image. So let me rename the variable to image collection so it can be descriptive. So, a feature collection of feature. So feature are more like vectors or image and for rasters, right? So yeah, that's the first variable, what you want to add to the map. Then the second one is how you want to style it. That's it, accepts the dictionary of styling, like how you want to style it. Let's say, for example, to show just band 4, by band 5. It accepts just 3 bands, RGB. So let's say you want to display just these 3 bands. So you're going to accept a dictionary of different parameters. Okay, let me just show you the function here. Map.add layer. You can see. So when you click on it, you're going to see what it accepts. Yeah, this one. So EE object, can be a collection, a feature, an image, a raw map ID. That's the object of the map. Then the visualization parameters. That's what I'm trying to do now. I'm trying to, select a particular band, right? The name you want to, give the layer. So that's the third argument. And that's what I'll call image collection. So that's the name. The name must be a string. You can see string. Well, it's actually optional, so you might not fill it with anything. Unique compulsory is just the object you want to add. That is, if I just say I want to do map.add layer and I want to add this image collection and I run it, it's going to work. It's going to add the layer to the map without any error or anything. But if you come to these layers, you're going to see layer 1. That's why it's advisable to, maybe give it a name. In case you're working on a lot of image, be able to distinguish them. Okay, this one is for image collection. This one is for NDVI. So that's what we use this one for, the third arguments, to give them a name. And it's going to show just band 5 and 3, right? So There are a lot of cloud covers here, so let's filter with cloud cover. You can also filter with cloud cover, so we can only get neat images. So, and how do you do that? You can filter with the normal metadata we have in with metadata we can filter filter metadata. That is, we can filter with metadata, and these are metadata. Let me just show you one image. And go to the properties. Yeah, these are metadata. So you can filter with this, with any of the items here. Let me see how to filter with cloud cover. I'll just say cloud cover less than let's say 10, for example. It's going to look at all these images and check for the one where the cloud cover, this parameter in the metadata is less than 10. So if I run this again, you can see we have just 15 now. And if you check the imagery, the cloud cover should be reduced. You can see there was 1 year before, but because it has a lot of cloud cover, it has been removed. And we only have images with low or no cloud cover, right? So let's do 432. Let me see how it's going to look like. Okay. Bands. Okay. That should be bands, not band. So I think the color has changed a little bit. So let me filter with less than 5 cloud cover. You can see, I think it has removed the 1 year. And we have just this one, and this one. Let me validate the study area imported. The same process. Map.add layer study area. Semicolon. So let me give it a name. No styling. I'm not giving it any styling. So I'm going to make this empty. Then to give it a name, I'm going to put this in a string and give it study area. So if I go to my layers, it's going to be a study area. But this is overlaying, that's why. So if I check this, I'm going to see my study area. If I check this, I'm going to see. You can see the imagery covering the study area perfectly. Let me say I want to, we have just 13 elements. These are image collection. So let me say I want to mosaic them. It's just very easy. I just call dot mosaic here. I'm going to mosaic the images for me, right? Let me say I want to clip to my study area, just to show the images in my study area. I'm going to call dot clip, and I'll pass in my study area. And it's going to show me just one shot image within my study area, right? So even if I want to say I want to export now, I've reduced a lot of megabytes. This cannot be up to 10 MB or maybe 20 MB maximum. Let me enhance the visualization of this image and see if it's going to improve the visualization. Yeah. So this is the Landsat image for my studio. There's still some cloud cover here, so I can check for another imagery with no cloud cover. This is raw imagery. You're right. This is raw imagery. So I can use surface reflectance image because I know that one has been corrected. The cloud cover has been removed. So I'll scroll down and check for surface reflectance image. I missed it. Sorry, that person should okay. This surface reflectance. So let me check this and import this. So let me just change this. Let me delete this. I don't need this here. Let me change this to image collection and I'm run the code. Image collection. Image collection, yeah. Let me try and run the code and see if it's going to work. Okay, I used Nansat8 for the variable. You can see Nansat8. I thought I used image collection. So let me see if it's going to work. Maybe without atmospheric cover or something. So I think it worked, but it still has some minimal atmospheric. Let me filter this by 3. So this 2018 or no wonder. Let me make this for 2020. So there's just so much flexibility in this platform. You can filter easily. 2020 has not very cover. You can do all sorts of filtering. So it's not as if you'll be downloading your own image and start doing the filtering on your. You can do the filtering right from here. There's also a way you can mask out this cloud cover. If at all you find any cloud cover, there's an algorithm for that. You go to Landsat and you go to Landsat A surface reflectance, for example. I think there's a script like that shows you how to mask. Let me click on C example. So click on C example. I think there should be a script. Yeah, this is a script. So if I copy this script, for example, and I put it here, just paste it here. Then I map it over this image. So map is a function for mapping a function. It's a super function. Mapping a function on all the image collection that you might probably have. F4, let's say 57, for example. I hope it's going to work. Cloud mask. Let me just copy this. I hope it's going to work. Okay, I think this is for Landsat 7, maybe. Oh, Landsat 7. Let me go back to. Let me select for Landsat 8. Those mapping functions have their different, like, they're using the bands in each distance to the map. So Landsat 7 band is different from Landsat 8 band. That's why it was showing me the error. But let me change it to this now. So let me hope it's gonna work. Am I still using Landsat? No, let me just copy this. Yeah, let me just use this image connection. Let me just copy this, basically. The image I'm using is not different from the one it's expecting. That's why it's showing the 0. So yeah, let me change this to image collection. And let me add this so it can filter to my study area. Let me comment this out. So that's mascara. Study area, image collection, line 19. So there's an error in this line. Let me see what's going to happen. Okay, yeah, I'm trying to click an image collection. Let me try something. Let me limit it. can also limit. Not spelled correctly. Let me try and. Oh my.